Transpiration is an important physiological phenomenon found in plants whereby they lose water in the form of water vapor from the aerial parts and into the atmosphere. About 98 to 99% of the water absorbed by a plant is lost through the process of transpiration. Hardly 0.2% is used in photosynthesis, while the remaining is retained in the plant during growth. There are four major types of transpiration: stomatal, cuticular, lenticular, and bark transpiration. Transpiration is an inevitable consequence of photosynthesis because for adequate photosynthesis to take place, a large surface area must be exposed to the atmosphere to absorb sunlight and carbon dioxide. A leaf which is permeable to CO2 will also inevitably be permeable to water vapor. Transpiration is essential for the movement of water and solutes from the roots to the aerial parts of plants. However, transpiration often tends to occur in excess, especially during hot, dry, and sunny days, resulting in excessive water loss from the plants and causing wilting of the leaves. Transpiration is therefore often termed as a necessary evil. Transpiration is affected by several external and internal factors such as light intensity, atmospheric temperature, wind, stomatal opening or closing, shape and abundance of leaves in plants, etc. In this experiment, we're going to focus on the major type of transpiration called stomatal transpiration. We're going to demonstrate stomatal transpiration in the leaves of plants through a classic experiment called the four leaves method. For this experiment, I'll be using some dicot leaves, though you can expand your scientific curiosity by using monocot leaves as well in your experiment to get a comparative overview of the extent of stomatal transpiration on both the surfaces of both types of leaves. For this experiment, we're going to need the following: two clamp stands or any other suitable support, thread, four freshly plucked leaves of similar size, petroleum jelly or grease, or even a lip balm. To begin the experiment, take the four freshly plucked leaves. Apply grease on the plucked ends of each of their petioles. In the first leaf, smear grease all over the leaf, both on the upper and lower surfaces. In the second leaf, smear grease only on the lower surface. In the third leaf, smear grease only on the upper surface. Leave the fourth one as it is without smearing any grease. Tie the petioles of the four leaves on a long piece of thread like you see here. Suspend both ends of the thread containing the four leaves on the poles of the clamp stands or whatever support that you're using. Leave the setup in bright sunlight for a few hours. Observe the leaves. You will find that some of the leaves have noticeably wilted to different degrees. The first leaf, with both surfaces greased, haven't changed much and remains about as fresh as when the setup was placed in sunlight. The second leaf too haven't changed much except that it has become slightly flaccid. The third leaf with grease applied on the upper surface have considerably wilted. And compared to the third leaf, the fourth leaf without any applied grease have wilted to the point that it has become shriveled and almost dry. From this simple experiment, one can conclude with a certain level of confidence that those leaves whose lower surface have been greased remain almost fresh and intact, showing that they haven't carried out transpiration much. This goes to prove that most of the stomata through which transpiration takes place in the dicot leaves used in this experiment are distributed on their lower surfaces. These stomata, being fully covered by grease, are unable to act as medium for the outlet of water from the leaves. We may thus conclude that stomatal transpiration is a major source of transpiration in the leaves of plants, and that the majority of stomata are distributed on the lower surfaces of the leaves in a dicot plant.